Imagine this. It's the 10th century. A Viking captain stands at the bow of his longship, surrounded by nothing but fog and gray water. His crew can't see the sun. The stars are hidden. No compass exists yet. So how does he know which way to sail? The answer lies in a stone. A crystal so rare, so precisely aligned with light itself, that it could pierce through clouds and reveal the sun's hidden location. It's called a sunstone. And for centuries, historians dismissed it as pure Viking myth, until science proved them wrong. The Vikings didn't just raid Europe. They crossed an ocean nobody else dared cross. They reached Iceland. They settled Greenland. And around 1000 CE, a man named Leif Erikson sailed to a place he called Vinland, which we now know as North America, 500 years before Columbus. No magnetic compass, no astrolabe, no sextant, just sunstones, stars, and pure navigational genius. This is their story. Let's start with the sunstone itself. The Vikings called it Solarstein, the sunstone. This clear Iceland spar crystal, Viking Sunstone, helps locate the hidden sun. In reality, it's likely Iceland spar, a form of calcite, a mineral crystal so optically perfect that it splits light into two rays that vibrate in different planes. We call this birefringence. As light enters the crystal, it splits into two rays that vibrate differently. Rotate the stone, and the brighter ray reveals the sun's direction, even beneath heavy clouds. Here's why that matters. When sunlight passes through a sunstone, it separates into two beams. As you rotate the crystal, one beam grows brighter and one grows dimmer. That brightness oscillation tells you exactly where the sun is, even if clouds hide it completely. Think of it like a light detector made of rock. The Vikings didn't understand the physics. They just knew it worked. That split is called birefringence. Two beams, two paths, one dependable cue that points back to the hidden sun. To navigate with a sunstone, a Viking captain would 1. Hold the crystal up to the sky, even on cloudy days. 2. Slowly rotate it while watching the light intensity change. 3. Mark the direction where maximum brightness occurs. That's where the hidden sun is. 4. Compare to memory. Vikings memorized the sun's path across the year, so they knew whether to correct course north or south. The accuracy? Between 1 and 6 degrees of error. Better than most ancient navigation tools. Measured accuracy ranged from just 1 to 6 degrees, remarkably precise. For reference, a magnetic compass has about +2 degree error, so a sunstone was just as good. But here's the problem. No sunstone has ever been archaeologically confirmed on a Viking ship. So how do we know Vikings actually used them? The answer is in the sagas, the ancient Norse stories passed down through generations. One saga, called Raudulf's Thatar, the Tale of Raudulf, describes a voyage in dense fog. The navigator holds a crystal up to the snowy sky and can see the sun's location as light refracts through it. Sagas describe navigators lifting a crystal and spotting the sun through snow-bright clouds, guiding the ship onward. Another saga, Landnámabók, mentions navigators using natural markers, birds, whales, and watercolors, but also hints at crystals for cloudy passages. The Vikings were meticulous observers. They knew every trick of the ocean. The sagas aren't fiction, they're encoded instruction manuals. So where did sunstones help Vikings sail? Route 1. Norway to Iceland, 970 km, 4 to 6 days. The journey starts in western Norway. Vikings navigated by following landmarks, the Shetland Islands, then the Faroe Islands. But the final 800-kilometer crossing to Iceland required dead reckoning and celestial navigation. This is where sunstones shined. Route 2. Iceland to Greenland, 970 km, 4 to 7 days. In 985 CE, a Viking named Eric the Red settled Greenland. The voyage required precise latitude sailing, keeping the same north-south position for weeks. Sunstones made this possible. Even in the constant twilight of Arctic summer, the crystal could pinpoint the sun. Route 3. Greenland to Vinland, Leif Erikson's voyage, 1000 CE. Around 1000 CE, Leif Erikson, son of Eric the Red, sailed west from Greenland to a place his father had heard about, Vinland. He found it. Archaeological evidence from Lonso Meadows in Newfoundland proves Vikings landed in North America. The entire route, 3,000 kilometers across the North Atlantic, relied on navigation tools like the Sunstone, plus Viking astronomical knowledge, wave reading, and pure skill. Sunstones weren't the only weapon in a Viking navigator's arsenal. Tool 1. The Sun Compass. Unertak disc. In 1948, an archaeologist found a wooden disc in Greenland with intricate shadow markings. It's called the Unertak disc, and it's likely a sun compass. By aligning the disc's shadow with the sun's position, navigators could determine latitude and time of day. It's a portable, organic navigation device, no minerals required. Tool 2. Star navigation. Vikings were master stargazers. They knew Polaris, North Star, stays fixed in the northern sky. The Big Dipper rotates around Polaris. Summer stars shift, winter stars stay constant. This knowledge let them maintain latitude even when clouds hid the sun for days. Tool 3. Natural markers. Bird migrations. Certain birds only fly within 100 kilometers of land. Whale populations. Species cluster around specific ocean zones. Seaweed type. Sargasso seaweed indicates warm Atlantic currents. Water color, dark blue. Deep ocean, green-blue are shallows. These weren't superstitions. They were hard-earned observations, tested over centuries. Here's where modern science validated the Viking myth. In the early 2000s, physicists at Abo Akademi University in Finland and the Royal Society in London decided to test whether sunstones actually work. They took Iceland spar, the same calcite found in Iceland and Greenland, and tested it under full sunshine, overcast skies, Arctic twilight, fog and mist. The results? Clear sunny days, accuracy +1 degrees. Cloudy days, accuracy +2-4 degrees. Fog, accuracy +5-6 degrees. Arctic twilight, accuracy +3 degrees. The sunstone genuinely worked, not as a myth, as applied physics. Even more remarkably, researchers tested other materials. Cordierite, +6 to 10 degrees. Tourmaline, rare in Viking trade routes. Mica, too opaque. Iceland spar was the Vikings' best option. Now, the honest truth, no sunstone has been found on a Viking ship. Not one. We have Viking navigational tools, compasses, the Unertak disc, astrolabes from later centuries, but no confirmed sunstone artifact. So why believe they used them? The evidence is indirect. 1. Sagas mention them explicitly, not as legends but as practical tools. 2. Iceland spar is found in Iceland and Greenland, places Vikings settled. 3. Lab tests prove the physics works, exactly as described in Sagas 4. No other explanation fits. Compasses didn't exist yet. No other tool matches the saga descriptions. 5. The Alderney wreck, hint. A 12th century shipwreck shows evidence of birefringent materials in its cargo. In history, sometimes the best evidence is consistency. The sagas, the science, and the geography all align perfectly. Vikings almost certainly used sunstones. We just haven't found the smoking gun yet. What does the sunstone tell us about Viking civilization? 1. Technological innovation. Vikings didn't invent the sunstone, but they mastered its use. They turned a rare mineral into a navigational system, the first feedback-based navigation device in history. 2. Cultural knowledge transfer. The sagas prove Vikings preserved knowledge through stories. They encoded technical data into narratives, ensuring accuracy across generations. 3. Atlantic dominance with sunstones. Vikings owned the North Atlantic for 200 years. They reached Iceland, 874, Greenland, 985, and America, 1,000, centuries before other Europeans dared try. 4. The end. Why compasses won? By the 12th century, magnetic compasses arrived from China. They were simpler to use, point and go. Worked in any light condition, night, fog, rain. Required no training in polarized optics. Didn't need rare Iceland spar sunstones became obsolete. But for 300 years, they had no equal. Interestingly, sunstone navigation mirrors a technique used by modern Polynesian wayfinders, navigators who sailed the Pacific using stars, waves, and natural markers with stunning accuracy. This suggests that ancient maritime cultures independently developed sophisticated navigation without modern instruments. The hokulea, a modern double-hulled canoe, has successfully sailed from Hawaii to Tahiti using only traditional Polynesian navigation. Similarly, modern sailors have recreated Viking routes using sunstones, proving once again that the Vikings weren't luck. They were masters of their craft. Modern sailors and researchers have repeated these methods at sea, confirming what Viking captains learned by experience. With practice, patience, and a simple crystal, the horizon opens, bearings hold steady, and long crossings become achievable without instruments. The sunstone is more than just a crystal. It's proof that ancient people were brilliant. They didn't have GPS or satellites, they didn't have steel-hulled ships or diesel engines, but they had curiosity, courage, and the willingness to master their environment. The Vikings crossed an ocean that would terrify most modern sailors. They did it with stones, stars, and stories. And that's a lesson worth remembering. Remember, curiosity and observation turned nature's light into navigation. Knowledge carried across oceans for generations. If you loved learning how Vikings conquered the Atlantic, like this video and subscribe for more deep dives into ancient navigation, maritime history, and the brilliant people who dared to explore the unknown. Next time, Polynesian wayfinders. How they sailed the Pacific with no instruments at all. Thanks for watching. Sail well.